Hello friends, welcome to my channel. Today's topic is memory organization of 8051. So 8051 has two types of memory. Random access memory RAM and a read-only memory ROM. So both memories are on-chip memory. The size of the RAM is 128 byte and the size of the ROM is 4 KB of ROM. So to access 128 byte of internal RAM, 7 bits are used. So using 7 bits, the address is generated and using which you can access the memory. So here you can see the sections of the internal RAM. So internal RAM is divided into 3 segments, which we will see in details later. Then there is an internal ROM. Internal ROM is of 4 KB, 4 kilobytes, and to access 4 kilobytes, 12 bits are used to generate the address. So address ranges from 000H to FFH. Apart from internal RAM and ROM, the programmer or designer of embedded system can interface external RAM and external ROM also. The size of external RAM and ROM could be up to 64 kilobyte each. So the programmer or designer can attach 64 KB of RAM externally to the microcontroller, as well as the 64 KB of ROM, external ROM, to the microcontroller. So when external RAM and external ROM is connected, the total size becomes 64 KB, and to access 64 KB of memory, 16 lines are used, and that's why the full capacity of program counter and a DPTR is used. Program counter and data pointer register is a 16 bit. So using 16 bit you can add this in location of external RAM and ROM. So this is the address range for external RAM and ROM when we are using 16 bit. So first we start with the read-only memory. So read-only memory is used to store the programs. Those programs are stored permanently, so you cannot change the program. But 8051 is having only 4 KB of internal memory to store the permanent program. And suppose if you want to upgrade the system, or suppose if you want to add some additional functionality, you need to write a detailed program, and obviously the size of the program could be increased. The situation arises when internal ROM is not enough to store your program. So in that case you need to interface external ROM. The external ROM is of 60 KB. Because internally 4 KB is available, the total memory which can be accessed by 8051 is 64 KB. But 4 KB is internally present, so up to 60 KB external ROM can be connected. So this external ROM works in conjunction with internal ROM. So when you are interfacing external ROM, this pin, external access bar pin, plays very significant role in determining from which memory the program should be fetched. So EA stands for external access enable. So this pin is designed to tell the information about the program storage, where program is stored, whether program is stored in internal ROM memory or external ROM. So when you are using internal ROM along with external ROM, EA is connected to 1, which indicates that program is stored in internal ROM and external 60 KB ROM. So here you can see the size of the internal as well as external ROM. Suppose if you are using only internal ROM, the range of the internal ROM is this. 00000 to 0FFF. So this is the internal ROM. And again, if you want to use external ROM, suppose if address goes beyond the address of the maximum address of the internal ROM, the automatically programs are fetched from the external ROM. So address for the external ROM is 1000 to FFFFH. So both memory are working together as a single memory unit, which providing you 64 KB of ROM memory. Another situation when you want to discard your internal ROM completely. You don't want to use internal ROM, you want to interface, you want to connect 64 KB of external ROM. But in that case, external access pin should be connected to 0. So this external access is the hardware input for 8051. It is used to discard the internal ROM. So when EA is connected to 0, which tells microcontroller that each and every instruction of the program is stored in the external ROM, and internal ROM is of no use. So it directly fetches the program from the external ROM. There is another type of memory which is available in 8051 is the random access memory. So random access memory is of 128 bytes. So 8051 has only 128 bytes of internal RAM. So if we want to expand the RAM memory, we have to use external RAM with proper addressing scheme. In 8051, the pin 7 of port 3 is used for reading signal, and pin 6 of port 3 is used for writing signal. So these two pins are used to provide a read and write signal. These read and write pins are connected to the RAM for reading and writing data. So you can connect 64 KB of external RAM to the 8051. So if you look at the internal RAM of 128 bytes, it has 3 sections. First section is of working register. Next section is the bit addressable memory area. Third section is the general purpose memory, which is used to store the data temporarily. So we'll talk about the different sections of the random access memory. So first section is the register banks or working registers. The 8051 has 4 register banks, with each bank having 8 registers, which are used in many of its instructions, many of its arithmetic, logical, and other instructions. Those registers are numbered from 0 to 7, like R0, R1, R2, up to R7. These registers are usually used to assist in manipulating values and moving data from one memory location to another. The size of the first section is 32 byte, and in that 32 byte there are 4 banks: bank 0, bank 1, bank 2, bank 3. These 3 banks are there. Bank 0 is the default bank. When microcontroller is reset, bank 0 is selected by default. So there are 2 bits, RS1 and RS0 are used to select the bank. So when microcontroller is reset, is RS1 and RS0 is 00 at that situation. So as you can see, each bank is having 8 register and bank 0 is selected by default. So these registers are 8 byte long. Individual register is 1 byte or 8 bit of long and used to perform byte operations. You can use those register by their name or address. As you can see, each register is having its functional name along with its address. So suppose if you want to access any register by its name, the instructions would be move a comma R0. The name of the register would be a part of the instruction, and beside register name you can see the instruction you can see the address of the registers. So by using address also you can access same register, but when you are accessing registers by their addresses, there is no need to activate the register bank. So like here in this instruction, move a comma 13h. So 13h is the register R3 of bank 2. So from this location, the content will be copied in the accumulator. So there is a kind of restrictions, you can say, when you are using a register by its name. As you can see, there are 4 sets of R0 to R7. Okay, and at a time only one set is activated. It depends upon the status of the RS1 and RS0. So suppose if you are specifying register name, so only register of the activated bank will be used. But suppose if you are using address of that register, there is no need to check the activation of bank at that time. You can access any register randomly by its address. So next is the bit addressable area. So bit addressable area is a 16 byte. So this bit addressable area is used for the bit operation. So if you look at the diagram, there are 16 byte and individual bit of each byte can be addressed, can be accessed. That's why it is used for the bit operation. So there are 16 byte and each byte is having 8 bits. Likewise, we have 128 bits, 128 addressable bits. So how to access bit addressable area? Suppose register bank and bit addressable area both are use same address. So if you look at if you recall the previous slide, 00 is also the address of the R0 of first register bank. So there are instructions which are used to differentiate between register and bit area. So in 8051 there are 109 instructions, out of which 97 instructions are the byte instructions which perform byte operation, and 12 instructions are the bit instructions which are used to perform on bit. So if you look at this instruction, move a comma 25, so 25 is the address and from that address data will be copied into accumulator. But now here 25 is this location, and from this location byte of data will be copied into accumulator. Because why so? Because move is the byte instruction, it operates on byte, whereas set B and clear are the bit addressable instructions. So it works only on single bit. So set B is used to set the particular bit, which is this. Clear is used to clear the particular bit location. So depending upon the instruction, the working of the data of the instruction is changed, whether it is a byte instruction or a bit instruction. After bit addressable area, there is a general purpose area which is used for storing the data temporarily. So why bit addressable area is used? Bit addressable area is used to mark the event or to store the event. So by setting up any particular bit or clearing any particular bit, you can mark the events. If you like the video, subscribe my channel and share it.